Hello, Keith Rucker here at VintageMachinery.org. Guys, and today I'm excited because it is a new machine day here in the shop. And we picked up a new toy here for us to play with out here in the shop, and I'm really excited about this. This is actually something I've been looking for a while. And what I've got here is a Sellers Model 6G drill grinder. And this is a bigger drill grinder. If you guys follow my channel a lot, I've got a smaller 1G Sellers drill grinder, which will basically grind, I think it's like 1/8 of an inch up to a 1-inch drill bit, smaller size drill bits. 1 inch, some people say, well, that's not small, but yeah, it'll go do up to a 1-inch drill bit. I've been needing, though, to be able to freshen up and sharpen my larger drill bits, 1 inch and larger, and that's where this one here will come into play for doing those bigger size drill bits. By the book, this one is capable of grinding drill bits from, 5/16, I think, up to 3 inches. So a little over 1/4 of an inch up to 3 inches you can do on this one. And realistically, I will probably use it for 1 inch and larger, because my other grinder will do up to a 1-inch drill bit. This will probably be for the bigger drill bits going forward. I picked this up when I was on my road trip going up to Arnfest. In fact, I actually picked it up at Arnfest. I had made this purchase, made a deal for it before we went up there, and had made arrangements for one of my viewers and one of the members of OWWM group, Doug Broberg. He actually brought this down from Minnesota. A friend of his was selling it, and he brought it down to me, and we put it on my truck, and it got hauled all over our road trip in the back of my truck coming back home. But we've got it back here now, and haven't had a chance to do anything with it yet. I thought we would go ahead and pull this thing out today and see if we can fire it up and maybe, get it running. I was told it was working, that it was completely functional. They did have to take a few things off of it to do the shipping, to get it down here, to make it a little bit easier to handle. We need to kind of get that stuff back on it. Today's goal in this video is, again, I just want to get it up and going. I want to get it where I can use it, operate it, and just kind of check it out, play with it, and try it out, do a little bit of drill grinding with it, hopefully. That's the game plan. Eventually, I would like to come in here and do a restoration on this machine, take it down, give it a good cleaning, repaint it, take care of any issues that may be in here. I don't even know what those issues might be right now. Probably change out bearings and stuff like that while I'm in there, and just get it in tip-top shape and have it going. But for right now, I just want to turn it into a user that we can use until we get a chance to put it in the restoration queue and do a full-blown restoration on it. It's a pretty neat little setup. Came, pretty much as you see here. One thing that I did get with it was it has a new, brand spanking new grinding wheel. The grinding wheel that's on here appears to be in very good shape, but they had an extra grinding plate wheel, so that came with it. So nice to have those, because these can be kind of expensive to have to go buy new ones. I think they're still available. I know you can still get them from my other sellers, but between the one that's on here and this one, I'll probably never need another one. I doubt I'll ever grind enough drill bits to wear 2 of these things out. Anyway, let's get in here, take a look at it, see if we can get her up and going. So let's just start out by taking a quick look at how this whole thing works. And I'm going to tell you guys right up front, I'm familiar with my smaller Sellers, and this one is very similar but a little bit different. I've never used one of these, so I'm going to have to kind of figure things out as we go. Probably be some trial and error here. But basically, you mount your drill bit into this holder here. I'll show you how that works in a minute. You got the grinding wheel up front. It can kind of come in and out. You can put a stop here. It holds it in place. And when you put your drill bit in here, this whole assembly kind of rotates to get that grind angle on it. Now you got this little piece here that holds the front of the drill bit, and back here in the back you got the piece that adjusts in and out that holds the back of it. Now most of the drill bits that are the size that we're going to be doing will have a center hole in the bottom. For example, this little taper shank drill bit, so you got the center hole in here, so that will support back here on the back. And then up on the front, you kind of lock that in place. Let me slide this back a little bit. So now I can kind of grip down on that. That holds the drill bit in place, and you pull the wheel up to it. It's back right now. I'm going to have to figure out how to adjust it up, get it closer. But you just kind of grind it, and this puts some relief on the back and comes back around when you do that. And when you get ready to do the other side, you just loosen it up, rotate your bit around, re-grip it. It should be positioned in the same depth because your back end hasn't changed, and you grind the other side. Hopefully that makes sense. And like I said, I'm going to probably have to get in here and figure out exactly how some things work on this. Got you guys looking on the back of the machine here, and there's a cover that covers all this up, and it's not connected right now. I'm just going to take it out of the way for the moment. And you can see this is where we got the flat belt that powers everything, but there's a counterweight down here in the bottom that came with it, and I was trying to figure out where it went. And I got some documentation. There's a little knob right here. This just fits right up on there. They had taken it off when they shipped it, so it wasn't swinging along on the everything, but that should just fit on there just like such. All right, I think I got it figured out what this counterweight is doing. So it's basically just putting pressure on this whole assembly. This assembly slides in and out. That's what moves that grindstone where you can adjust it up and forward. There's a knob up on the front, or a hand wheel, and when you do that, that adjusts the cutter or the grinding wheel in and out to the drill, so you can adjust how deep your cut is and whatever, and move your grinding wheel in a little bit deeper. And that's just putting some pressure on there. I don't know if you'll be able to see it or not, but when I turn this handle on the front, this is actually coming towards me. And I did notice the other day I was playing with this, I was turning the handle and the wheel wasn't moving. And the reason was it didn't have that pressure on it. So that's what that does. Well, let's go around here, and there's a little table I need to get mounted on here, and I think we can see if we can get this thing wired up and try it out. There's a little table piece that mounts right here. They had removed that again just to make it easier to haul. They put the 2 bolts back in here. I'll go ahead and take those out. And this is the little table, that plate that mounts right here. Let's go ahead and get a bolt started in that. All right, so the main purpose of this plate right here is that there's a coolant pump down here that pumps coolant, and this catches the coolant, and this one, it drains over into this, which drains back over. This catches anything that kind of comes back over here, and there's a little spout back here that just drops back down into the coolant tank. So that's just basically to contain coolant, to keep it from flowing everywhere and making a bigger mess, because you can get some coolant that runs back down this end. All right, let's see if we can get this worked out here. So this arm here, you can see there's a key way that's cut all the way down through here, and there's also a key in this piece, but the key's missing. So we need to take this off and figure out what we can do to get a key in there and make sure that that slides and stays in the proper position. Clean this keyway out a little bit. I'm just going to put a little WD-40 in there and take a little pick here, just kind of get any crud that I can get out of there out, because there's a bunch of just junk down in that keyway. Now I've got a little file. I'm just going to kind of come in here and make sure I don't have any burrs on the inside of that key. I'll do the front and the back. All right, I've got a key in there. It seems like it's staying in place pretty good. I'm probably at some point in time just going to drill and tap a couple of holes to kind of hold that in there so it won't slide around. But for right now, I'm gonna see if we can just put it up on there. And it is kind of coming out the back. Let's see if we can get it up in there. All right, I think that's going to work for right now. Well, we'll make it. I don't want to, I'm just want to try to get this thing going right this minute. Eventually I'm going to have to deal with this keyway a little bit more, but at least we'll get it where we can play with it for the moment. All right, I think this is going to be fine for the time, right this minute. Like I said, I just want to get it in here where I can play with it right now. We're going to do some work to this whole setup at some point in time, and when I do, I'm going to probably, well, not probably, I will take care of that keyway a little bit better. Also, I noticed that there's some play in this whole shaft. We're going to have to deal with that, and it looks like that's been broken and brazed back together at some point. So that may be an issue that we need to go in there and do some more repair work, get a little bit tighter fit. Looks like they may have brazed that back together and it's not as tight as it needs to be. That can be fixed. We can work with that. All right, so let's see what we got here. It looks like we've got a disconnect, says motor starting switch, although we got a push button up here that's flopping around. I'm not sure exactly what's going on here. We'll just tear into it and see what we can do. So take this screw out of the top over here. Got some tape covering up some holes here. It looks like where there was probably either a reset or a starter button at some point in time. All right, we got a motor starter in there. So it looks like to me that what has happened here is we've got this box, but this is not the starter that was originally in this box. At least that's my guess. Yeah, I can verify that because this has got a sticker in here that says General Electric, and this is an Allen Bradley starter that's in it. No big deal, it's just they were using this box as an enclosure and got duct tape on there covering up what was originally probably the reset button. I don't understand why we've got a separate switch over here. And then of course we got this push button starter station up top. All right, before we go any further, just had a chance to look at things a little bit closer off camera, and I got a better idea of what's going on here. So this does serve a purpose. We've got this switch over here. None of this is hooked up right now. This motor starter here is what starts the main motor. So when you hit this button, that's going to turn on the motor that will start everything spinning. This over here is for the coolant pump. It's a separate switch. So the coolant pump will turn on separately, and it has its own motor starter and heaters and stuff in it. So yeah, I kind of like that. I may not always want to run the coolant pump. You know, this way I can have my choice as whether I turn it on or off. I'm still not crazy about this motor starter just kind of hanging in this enclosure and not being properly mounted, and also the duct tape over the holes in the front. So we may, let me go see what I can find. We may keep this switch, but we may change this one out, or at least put it in a different enclosure. Let me go dig around and see what I can find. I've pulled out this motor starter here, and there's nothing wrong with this starter. It just, I'm not crazy about the enclosure that it's in. It's not the right enclosure, and really need to get the right enclosure for this thing if we're going to use it. The other thing that I've noticed when I took it out is that the coil in this motor starter is a 440 volt coil. Now that tells me that they probably have this machine set up to run on 440 volts, 480 volts, whatever you want to call it. So I need to get into the motor and check the wiring on it, and if needed, change that out. running on 220 volts or 240 volts, really shouldn't use this. You could use this starter, but I'd have to change the coil. I don't have a coil. So we will set this aside. I'll put it in my stash of electrical stuff. It'll probably get used one day on something where I have a proper enclosure that it can go into, but probably not going to use it on this one. Now, I dug around in my stuff, and I've got this square D. This is a NEMA size 0, which will do for 230 volts, 3 horsepower maximum size motor. I'm pretty sure that we're at no more than 3 horsepower. I need to look at the motor plate on it to make sure, but we're probably going to use this one. And this one has a 208 volt coil. We'll be running it on 220, 240, what are you going to call it, which was in the range that it can be used. So, you know, this one should work with this setup and the voltage that we're going to. So we'll basically just swap these components out. Like I said, I need to get to the motor and check the wiring on it and make sure that we got this wired for 240 volts instead of 480. And I'm not sure how we're going to get to the motor. It's up underneath the bottom here. There is an opening right here, but not a whole lot of room to get to it. So let me figure that out, and we'll be back in a minute. Well, I thought this was going to be easy. Come out here today, wire this thing up, check it out. Ain't nothing ever easy, is it? So upon further inspection, the only way to get to this motor, at least to what I need to get to, there's no access points or anything in there. There is a hole in the front, but you really can't access what we need to access to check things out. The only way to get it is to pull the whole motor out. And it's bolted up on the back, and the whole motor just slides right out of this hole. So, yeah, I wasn't planning on this, but it's got to be done. I need to make sure that we got the voltage correctly. Based on the motor starter, my assumption is that this is wired for 480. We need to be wired for 240. Yeah, so it needs to come out and check it. So I'm going to be really upset if I take it out and it's wired for 240, but there's no way for me to verify it other than to do this. That's all I know to do. So we're going to take this counterweight back off, take the belt off. I'll pull those bolts out of there, and we'll see if we can get this motor out. I need to see the motor plate on it also, so that I can see how many amps this draws at full load, because we're going to probably have to put different heaters in that motor starter to match the motor to give proper protection. I also need to check this coolant pump and make sure that the heaters are right for it. If it's wired for 480, it's probably got going from 480 to 240, we're going to reduce the voltage in half. We'll double the amps. So if those are the motor starters or the heaters for 480 volts, they're going to be at half the amps that what we would need at the lower voltage. So those are going to need to be changed. I'm sure all these motor heaters are obsolete. We're going to probably just have to find new old stock somewhere. Usually I can find them. But anyway, yeah, this is turning into a bigger project than I thought. Surprise, surprise. Let's get at it. Now, let's see how difficult this is going to be to get out. So far, so good. All right, that wasn't too bad at all. All right, we can see our leads coming out. We just got a wad of wires there. All right, there's the motor plate. It's covered in crud. Let me get that cleaned up where hopefully we can read it. Looks like it's a Delphi 3-phase motor, 2 horsepower, 1725 RPMs at 60 cycles, which is what we are. It also has it for 50 cycles. At 50 cycles, it's 1435. Service factor of 1.15. at rated volts is 60 cycles, and then you got low voltage 220, high voltage is 440. Draws 6.8 amps at 60 cycles, 6.8 amps at 220, and 3.4 at 440. And it shows the wiring diagrams on the wires. There's 9 wires coming out of here, numbered 1 through 9, and depending on how they're tied together will tell me whether this is wired for either the low voltage or the high voltage. So we're going to pull this cover off of this. I can see the numbers here on the wires coming out of the motor, and we'll figure out how this thing is wired. Give me a minute to get this sorted out. Okay, so our motor is wired on the high voltage here, so I'm glad we pulled this apart. So you got our 3 leads coming in here. These will come in from the power coming in, and according to this should be for high voltage, this is terminals 1, 2, and 3. And if I look here, there's number 1, that one's number 3, and that one's hard to read, but it's a number 2. And then you've got 3 more sets of bundled wires. 4 and 7 are bundled together, 8 and 5, and 9 and 6. This is 5 and 8. This one here is 6 and 9. And this one here is, I think, 7 and 4. They're hard to read. Yeah, that's 4 and 7. So what I need to do is pull all these apart. My numbers are hard to read, so I think what I'm going to do is go ahead and make some new labels to go on these just to make them a little bit easier to read. We will pull everything off and we'll rewire it. Now for the low voltage option, your terminals are going to come in, the wires will come in, and they'll be, so your internal wires coming in will go to numbers 1 and 7 will be tied together, plus the line coming in. 2 and 8 will be tied together, plus the line coming in. 3 and 9 will be coming together, plus the line coming in. Then we'll tie together 4, 5, and 6 back here in the back. So you can pretty easily tell this is the high voltage option because everything has just got 2 wires on it. When it's on the low voltage, everything is going to have 3 wires bundled together. So I'm going to give me time to make some new labels, get those put on here. We'll get this rewired together for the low voltage, and we can put all this back together. All right, so we have all of our wires disconnected, and these were all basically just screwed together. They got the little connectors on the end, and they were bolted together and then taped up. And we're going to do the exact same thing here. I did go back and put new numbers on all these. I left the old ones on there as well, but some of them were hard to read, so I just went ahead and renumbered them all. And I just have one of these little books here that has numbers and letters in it. They're just little stickers. You can get these, you know, home improvement store, whatever, to put them back on there. And we're going to go ahead and get this wired up for the low voltage option, 220 volts. And first thing I'm going to do is terminals 4, 5, and 6 get put together. All the other ones will have leads coming into them. So I'm going to pull out number 4. There's number 6. And here is number 5 up here. Let me kind of get these bundled up together. 4, 5, and 6. And what we'll do is we'll take a screw and we'll just put all these together. I'm going to take a pair of pliers here and grab a hold of that. We'll take a screwdriver and tighten those up. All right, so that set is together, and what I usually will do is I'll wire tie them together just to kind of keep them bundled up. Let me get some wire ties real quick to do that. And we'll just put that on there right about there. Just clip that off. So the rest of them are going to have leads that come out that will actually be power coming into them. Now I've got the original wires here, but I think I'm going to just go ahead and put some new wires on it just because. I don't necessarily have to, but I'm just going to go ahead and get me 3 new wires. I'm going to crimp some ends on them, and we'll have some new leads coming in there to them. All right, I got some 10 gauge wire here that we'll be using for our leads coming in. Overkill, this motor's only drawing 6.8 amps, but I'd rather just go ahead and put some heavy duty wire in here. Now, my wire colors, I could have just gone with all black, have been just fine. 3-phase power, typically you're gonna have, your hots are gonna be red, black, and blue is the color for the 3 phases. So I just use red, black, and blue. Like I said, for application, you could have just used really all 3 colors, or all 3 of the same, any one of these colors would have been fine, but I like to differentiate my phases. It's just the way I like to do it. So for these, 1 and 7 will go to one terminal, 2 and 8 will go to another line, and 3 and 9 will go to another one. So here's number 9. I need number 3 to match up with it. There's 3 and 9. Let me just verify. 3, 9 will go to a phase. So I'm going to we'll put this one in between those 2. Put us a screw through there. Put us a nut here on the bottom. And we'll tighten it all up. All right, we've got all of our leads connected now. Again, 1 and 7. This is 3 and 9, 2 and 8, just verifying, and then 4, 5, and 6 right here. Now, when you use this type of connector where you have the screw holding everything together, this is kind of an old school way of doing things. It's still completely valid. In fact, this is probably better than most connections that you make. But when you do this, you're supposed to wrap this up in what's called friction tape. And you can still get friction tape. A lot of people have probably seen this. It looks like electrical tape, but this is kind of a cloth-based thing. A lot of times you may have seen this and not known what it was for, but it's made to be real durable to cover this up. So we'll wrap this in friction tape, and then you wrap it again in electrical tape, which is the more plastic thing, but this friction tape is better around all this metal. So we're just going to kind of come in here with the friction tape, and we'll just wrap everything up real good. And then, like I said, we'll come back over it with the electrical tape after we do this, but get it covered with the friction tape first. And I'll do each one of these connections both in friction and electrical tape. With that, we got everything wired back up. I think all I'm going to just do is just wrap all that up in some electrical tape, just because this does not have this. Usually, you have some type of cover covering all this stuff up. This particular setup, there is no cover, so I just want to make sure everything's very well protected. So just erring on the side of caution here. So I'm going to just wrap all this bundle up now. And all right, we're ready to button this back up. All right, I got my motor ready to go back up in there. I've already got my wires kind of fed through where they should go out. And I don't know how much trouble this is going to be to get back in here. It's heavy, and it's just me. All right, I think that's hanging on that one. Now I can tighten them all up. All right, that wasn't so bad. So this is the new motor starter that we're going to put in here. It is a NEMA size 0, so basically it will go up to on 220 volts, 240 volts, 3 horsepower maximum. We got a 2 horsepower motor, so we're within range there. And this one does have a 220 volt, or it's actually 208 volt coil. That's within the range. It'll work fine. So this will start on the voltage that we're going to be giving it. Now, a couple things on motor starters. These are basically the switch that turns it on. So this is made where when you push the button to start the starter, there's a magnet in here in this coil that causes that magnet to close, and when it does, that basically turns the power from the lines coming in going to the motor. So it's your switch, and then when you hit the off button, it releases the magnet in the coil and it turns it off. So it's the on-off switch, but a motor starter also serves one other purpose, and that's overload protection. And it does that through these heaters down here in the bottom. These heaters basically, you change these out depending on the amperage that your motor is rated for. So just like a circuit breaker protects your wiring in your house, so if you've got a 20 amp breaker, which is what most of my 3-phase breakers are, you know, the wiring is rated for 20 amps maximum, or maybe a little bit more than that. But if you go over 20 amps, those wires can get hot and it can cause the damage to wires or even cause a fire. So if you draw more than 20 amps on a 20 amp circuit, it will trip the breaker. The motor starter kind of does the same thing. But you rate this for whatever amperage that your motor is rated at. And we looked on the motor tag when we had that apart, and I need to go back and look. It was 6.8 amps, I think is what it was called for. So to protect that motor, we want to make sure that we're never giving it more amperage than what that motor is rated for. And again, I just said, I've got a 20 amp breaker on my electrical stuff, but my motor is only rated for 6-something amps. So if I draw 20 amps and it trips the breaker, well, I've probably already fried my motor because my motor's only rated for 6.8 amps. So that's where these heaters come into play. This is basically, you can kind of think of it like a circuit breaker, so that if it draws more amps than what your motor is rated for, it will trip this starter. So basically, whenever that happens, these are actually mechanical heaters, and they actually call them heaters because they get hot. There's a strip in here, this little piece back behind it. It's different thicknesses for the different amperages, and when this gets to a certain temperature, it will physically cause this to trip out, and then that basically is like hitting the off button. It causes the motor to shut down, and that protects your motor, keeps it from getting too hot, keeps it from ruining that motor, because again, if we waited on it to draw the 20 amps that the breaker is set on, we'd be way overboard. Now the problem I've got though is, you know, I picked this motor starter, and I looked at the heaters that are in here. This is a B6.9 is the heater that's in here, and I need to actually size my heaters based on the actual amperages that I need to run. Now, you can go on the internet, there's charts, you can look these up. Now, inside the cover on mine, there's a sticker in here, and I know you can't read that, but there's a chart in here that tells you what heater you need for how many amps you're doing. And for mine, I think it was 6.8 amps, and in the chart, 6.4 to 7.13 amps needs a B10.2 thermal overload heater. I've got B6.9s. I can look in here. The 6.9 is rated for 4.1 to 4.88 amps. So these are underrated. These will trip before we get to the 6-point-something amps. Now, in all reality, it probably would work, but it would trip out way too early. So I need to change these heaters out as the bottom line. And I do not have a B10.2. I've got some ordered. These are, I don't think that they make them anymore, but you can find the new old stock ones. I just went on eBay. I was able to find 3 of the B10.6s. I do have some B8.2s, which are pretty close to the rating. So I'm going to change these out and put these in there temporarily until I get the proper heaters to go in this. and it'll work until we get here. These would probably work fine, but at least temporarily, but I'm gonna go ahead and put these 8.2s in. The 8.2s are rated for, let's see, 8.2, 5.2 to 5.73 amps, so basically just about an amp under. So like I said, these will probably work, but when my proper ones come in, I'll swap them out. This is something you need to look at when you're changing motor starters. You know, if we just went from the 480 volts to the 220 volts, I told you earlier, when you decrease your volts, you double your amperage. So at 480 volts, that same motor runs on half the amperages. So we had, what, 6.8 amps? So that would be 3.4 amps at 420 volts. So if we just said, okay, we're just going to feed it 420, my heaters would be half the amps of what it needs to be, and they would probably trip out too soon. So anytime you're changing over your voltage, you need to check your heaters and make sure you have the right heaters. All right, I'm going to swap these out. I'm probably just going to go ahead and just wire this up. I've actually done a video on how to wire up a motor starter before, so I'm not going to go over all the details on that, but we'll get this hooked up and we'll get it checked out and running. Well, this was supposed to have been a quick and easy video, but as usual, things get complicated. Changing out this motor starter, not a big deal. Boy, is it time consuming. It seems like it takes forever to do this. And then too, I had misplaced my wiring diagram on how to do this, and I had to go figure out all that again on getting the switch done. But we've got this done, and replaced out the motor starter. We've got it rewired to run on 240 volts. And when you hit the start button, it starts. And when you hit the stop button, it stops, just like it's supposed to. So I think we're ready to move on. I will comment that I have not messed with the coolant pump yet. I'm assuming that it is also wired for 480 volts, and so it's being fed 240 right now. So I need to deal with that, but for right now, just playing around with it, we're going to try it out without coolant. I think it'll be fine. So let's see what we can do. I've got the drill bit in here, and I've never used this particular model machine, so this is going to be a little bit of experiment and play, but let's try it out and see what happens. Just so you can see what's going on here. When you turn the big wheel on the front, that moves the grindstone in and out. It also kind of goes back and forth, but I need to get it going where it's just kind of touching here. I don't know exactly. It'll come way back, and it looks like it's got a range right here. There's a little stop. It almost looks like it needs to be a little bit farther stopped. There is a screw in there. I can probably adjust some of that. Let's just play around with it and see what happens. Let's see. I don't think I'm touching right now. So the idea here is that you rotate this around to get your grind. I'm going to bring my wheel up to where it's just touching. There we go. So that puts a little bit of a back grind on it. And then I'm going to pull my wheel back. I'm going to rotate my drill bit 180 degrees. We'll clamp it back down. Pull this back up. We'll rotate that one around. Bring my wheel in a little bit more. Not hitting on this side. Maybe barely at the bottom. Do another feed here. I can tell a couple of things. Number one is my belt needs to be tightened up. And also I can tell that this wheel needs to be faced, or yeah, dressed. I don't have a wheel dresser for this. I'm gonna probably have to come up with something, but we'll figure something out. And I'm just gonna take a really light pass here to kind of finish dressing this. I'm gonna flip it around. Take one more cut on the other side. And we have one freshly dressed drill bit. Like I said, I can tell there's some things we need to do to improve things. I need to get the coolant going for one thing, because I can see it getting red hot there, which doesn't help, but it's working. It's working. I think we got some good bones here to work with to get another good usable machine in the shop. Well, there we go, a quick introduction to this new machine for the shop, my Seller 6G drill grinder. Like I said, we've got some stuff I know I need to get done to it before I really start using it too much. I need to get that coolant pump taken care of. I'll do that off camera. It's just time consuming to do this electrical work. We can tighten this belt up. I think the leather belt is fine. We just need to take about a, I don't know, ½ inch, ¼ inch or something out of the lacing here and relace that, tighten that up, because we were getting some slippage on this belt where it's just a little bit too loose. I need to figure out how to dress this wheel. I do have a manual on this, and it talks a bit about that. I do not have the wheel dresser that came with this or that goes with this, so I'm gonna have to come up with something there to do that. The other thing I'll mention is that these little holders that hold the drill bit, there's about 3 or 4 different sets of these that would have originally came with this grinder for doing different ranges of drill bits. I've only got the one set that came with it. I need to see if I can find the other sizes. I know that they're extremely difficult to find, but if anybody knows of the holders for 6G sellers, let me know. There used to be a guy that I was in contact with on my other sellers that had a bunch of new old stock parts, and back when I first got that grinder, I had talked with him several times, and I called out there one day and he had passed away, and now the business seems to have disappeared. So I don't know what happened, if they had parts, if that stuff's still out there or not. If anybody knows, again, let me know, because I would like to see if I can find some more of those different bits to hold the drill bits for the different sizes that this one would have taken. Eventually, guys, one of these days, I think I mentioned this before, I do want to take this and do a full-blown restoration on it, but for right now, I just want to get it up and running where I can use it. And before I do any really major grinding, I need to take care of the few things we just talked about: the belt, the coolant pump, getting the wheel dressed, and yeah, I think we'll be good to go from there. But I am excited to have this in the shop. I have had the need to sharpen some bigger drill bits, and even though it's not tuned up right now, I can tell that's a sharp bit. That bit is ready to roll, and it's going to do a good job for me, I am quite sure. So with that, that's going to be a wrap, guys, on this one. Hope you enjoyed seeing a little bit about this new machine, and you'll probably be seeing more of this as we continue on and get to play around with it some more and get to use it some more in the shop. So with that, we're going to sign off. As always, thanks so much for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Hit that bell icon up there, get notifications when new videos are posted. Big, huge thank you those who support the site financially through Patreon and PayPal. There's links for that down in the description below. That's something you want to help out with. It really helps out a lot around here. And with that, yeah, we're going to sign off. We'll catch you on the next video again. Thanks for watching.